Only legends knows how to solve this type of Maths Olympiad problems. Are you? Let's find the value of x in 9 power x minus 3 power x is equals to 1. Our goal is to find the value of x that can satisfy the given exponential equation. So first thing we have to do to get the value of x is to look at 9 and 3. They are of common terms because 9 can be expressed as 3 squared. So instead of writing 9, simply write 3 squared, then raised to the power of the resisting power x, then minus 3 power x is equal to 1. What do you understand here? You understand that we have 3 squared x. We can now say from the laws of exponent, we can now use the law of exponent which says that whenever you have a to the power of b raised to power c, it can now be seen as a power c raised to power b. The reason behind that is that multiplication is commutative, so we can actually flip the positions. So if you have this, we'll now apply this particular rule to this term. So instead of writing 3 squared, I can now write 3 power x, then squared minus 3 power x is equals to 1. They are all the same thing when you apply this rule. So here, since we have this, I can now say, let y be equal to 3 power x, so that I can rewrite the whole exponential terms to be in terms of y. So if I do that, what do you observe? You can now see that I have y is now 3 power x. I'll now have y squared minus 3 power x is now y is equal to 1. These have now changed from exponential equation to quadratic equation. So I'm going to solve this. So to solve this, you can now see I can rewrite this to be that y squared minus y. I will subtract 1 minus 1 minus the 1 is equal to 0. This is clearly the general standard of quadratic equation. So for me to think, can I solve by what factorization method? Is there any number that multiplies to get minus 1 and adds to get minus 1? I think no. So I'm going to use general quadratic formula to solve. In general quadratic formula, we know that x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? Where we know that a is the coefficient of y, b is the y squared, b is the coefficient of y, then c is the last term, this. So from here you can now see that our y is now equal to minus, our b is minus 1, minus minus 1, plus or minus the square root of, our b is still minus 1 all squared, minus 4 times our a is 1, then times our c is the last term, minus 1, divided by 2 times 1, because our a is 1. So here you can see I have it to be minus is plus, you have it as 1, plus or minus the square root of 1 squared is 1, right? Then minus 4 times 1 is minus 4 times 1 is plus 4. Plus 4 divided by 2 times 1 is 2. So this can now be simplified to be 1 plus the square root of plus or minus the square root of 5 divided by 2. And that's the value for y. So we say that y is equals to 1 plus or minus square root of 5 over 2. So for y1, we can now say that y1 is equal to 1 plus square root of 5 over 2. And we have that y2, which is the second value, is equal to 1 minus square root of 5 over 2. Okay? So these are the two possible values for y. But remember, we said initially that our y is 3 power x. So we can now write that 3 power x, which is the y, is now equal to, we now have 1 plus root 5 over 2. Okay? So the best thing we have to do, since they cannot be expressed in the same base, is to take the log of both sides. So if you take the log of both sides, we have it that log 3 power x is equals to log 1 plus root 5 over 2. So this logarithm allows us to multiply the power to the log. So if you multiply the power, you can now see that x log 3 is now equal to, you can now see that whenever we are dividing any number in logarithm, we are free to subtract the numbers in the same log. What I mean is that we can write it as log of 1 plus root 5 for the numerator minus log of what? Minus log of what? 2. Okay? So here we now divide through by log 3 and divide through by log 3. If we divide through by log 3, x will now be equal to, I can split the log. Okay, splitting this fraction will now be log of 1 plus root 5 divided by log 3 minus log of 2 divided by log 3. Okay. If you apply change of base, you see that x is equals to, keeping the same base, we can now have it to be log of what? Base 3 of 1 plus root 5 minus log of base 3 of 2. And that's the actual answer. This can now be further seen as x is equals to log of base 3 of log of base 3 of 1 plus root 5 divided by 2. And that's the what? Answer. So this is the actual value for x. If this video is interesting, please do well to like, comment, and share your thoughts.